So I don't know if you saw my last video, but in my last video I was talking about how hopefully things were going to slow down and I was going to be able to work on my garage a little bit more. That didn't happen. This is the first day in a couple weeks I've been able to do anything. So I'm going to try to get a little bit of electrical done. So before I get started, I thought it would be beneficial to people out there to kind of explain some of the calculations. And if you're ever wondering about, what size breaker do you need for certain appliances, or how many appliances or how many different things you can run on a circuit, I'm going to try to answer some of those questions today. So to start out, just consider your breakers. You have a breaker here, 15 amp, and you have a breaker, 20 amp. These are typically used for lights. These are used for pretty much everything else. And by everything else with a 20 amp circuit, I mean all your plug-in outlets throughout your house, things that you'll plug your blow dryer into, or a mixer in the kitchen, different things out in your garage. So let's start out with lights. Let's say you're trying to determine how many lights you can put on a circuit. What you want to do is use this equation. So watts equals amps times your volts. So your volts are always going to be 120 in your house. So that's kind of a constant. Your amps, you may not know yet, but whenever these corporations try to sell you stuff, usually they'll put the wattage on your light fixture. So say for your watts, say you have a 60 watt light bulb. So you have a 60 watt bulb equals, we don't know how many amps, I guess if you're into algebra you can use next there, times 120 volts. So using some mathematical calculations, this is going to draw a half an amp. So in your circuit, let's say you did everything correctly, used a 15 amp breaker, and now you have a 15 amp circuit. So how many lights can you put on this circuit before you'll trip this breaker? So you might think that it's 30, but actually the way breakers are rated, they're actually going to trip out at about 80% capacity, which means a 15 amp breaker will trip out about 12.5 amps, 20 amp breaker about 16 amps. This is going to trip. So when you think about this, think about, and this isn't, as soon as it hits 12.5, it's going to, obviously there's a tolerance to it. So as long as you kind of keep this calculation in mind, and, you understand this equation and what the wattage is on your fixture, then you'll know how many of those fixtures you can put on your light circuit. So for my lights, I'm going to be using 15 amp circuit, and I have light fixtures that are 100 watts, and they're LEDs, but they're like a 300 watt equivalent. So they're 100 watts equals, I don't know how many amps, but I know that it's on a 120 volt system. So each one of these lights is going to draw about 0.84 amps. I have a 15 amp circuit, and this is important because the way I'm going to wire my garage, I'm actually going to run only 2 circuits. So maybe when you're wiring a garage in a couple different rooms, that are close together, maybe you want to run them all on its own circuit. You can do whatever you want. For my garage, it isn't that big of a deal. So I'm going to have my main lights and a couple outside lights on one circuit, and then all of my side lights that I have under those beams that I made, those are all going to be on another circuit. So I'm going to have about 6 of these fixtures. So I'm going to be well within my 15 amp breaker here. And then I'm going to have another 8 or so that's going to be on this other circuit. So I'll still be well within the amperage of this breaker. For the 20 amp circuit, it'll have a 20 amp breaker. This is going to be a little bit more complicated because I got to think about what I want to run on each circuit. So in my other garage, I have an outlet that is dedicated to welders. So it is a breaker that comes straight into my outlet, and that's it. I don't have any other outlets or anything, because when I plug in that welder, I want to make sure that it doesn't trip out. So something else I should mention, I'm going to say things like 110 volts and then 120 volts. So whenever they talk about voltage, they'll talk about 110. When you go measure it in the wall, it's generally like around 120, 121, somewhere in there. So if I talk about like a 110 volt welder, I'm actually talking about 120 volt, or a grinder or whatever. It's actually going to be 120 volt in the wall, even though they'll talk about it like it's 110. I don't know why it works that way, but it does. So let's say I want to run my welder. So the reason I have it dedicated to one outlet is because I don't want a fan running and a couple other things running, and all of a sudden I start welding and it kicks out. But let's say I have another, circuit, and I have, let's just say, 3 outlets. Well, let's say I want to plug in a grinder to this one, and I have, you know, a fan, and then maybe I have a refrigerator or something. So if I'm going to sit here and use my grinder, let's say a grinder will draw about 7 amps. Let's say the fan running has about, say it draws about 3 amps, and the refrigerator is maybe about 2, well, probably let's just call it 4 amps. So we're about 14 amps, so we're well within the 20 amp, even though this is constantly running, this is constantly running, and then, you know, I'm going to turn the grinder on, use it for a little while, and then stop. So a few of these things I can have plugged in, no big deal. But then let's say that we have something else, I don't know. I don't know, let's say my wife comes in and plugs in a hair dryer. So all of a sudden this is going to start drawing, you know, another 8 amps, something like that. Now I'm well over and it's going to trip out. So you want to make sure that you understand what you're going to be doing whenever you make these circuits, you know, whenever you wire these circuits. So it might be safer, you know, if you're going to be working in a garage, maybe to have more circuits. But there's also something else. Say you have a 20 amp breaker, and let's say that you have, I don't know, let's just say you have 50 outlets. Outlets times 50, you got 50 outlets on here. But let's just say you're not using them all. So say you just want to have outlets in different places so you have access at different times, but you're not going to be using over the 20 amps, then you're fine. You can have as many outlets on here as you want. And then as long as you're only using, you know, a couple at a time and you don't go over the 80% amperage of the 20 amp circuit, the 20 amp breaker, you'll be fine. So to kind of put this in a practical standpoint, let's look at what I'm going to be doing. The lights, you kind of already understand, like I explained. All the lights under here, and then in the office, and the other couple lights, they're all gonna be on one circuit, and then all the main lights here in the middle, and the outside lights up at either end of the gable end are gonna be on another circuit. So that's not even a big deal, I'm not worried about that. So this is what I'm talking about, having dedicated circuits. This, or dedicated outlets, we'll call them. So this outlet comes up, comes into the panel box. So I know I can comfortably plug in a welder, a smaller welder, a 110 volt welder, and be able to weld all I want without tripping the breaker. I'm also gonna put another one here, just in case I wanna plug in a plasma cutter or something, just for the convenience, so I don't have to unplug and replug stuff in. In this little area where I'm gonna have my tool bench here, I'm gonna have a Ryobi charger here, and I'm just gonna put a few outlets along here, because the most I'm gonna do with this is maybe put in a small drill press, maybe like a little bench grinder, and little few things here and there, but I won't be using them all at the same time. And so I know I won't go over the 16 amps of the 20 amp circuit. So I'm gonna put 3 outlets in here, and I'll be totally fine. This next little area, it's full of garbage, is gonna have my wood stove, and I'm gonna have my chainsaw sharpening area over here. So one circle will easily take care of this area because I'm only going to occasionally use the sharpener, and then I'll have a fan for the wood stove, so that's no big deal. Over along this wall, maybe another circuit, just because I'm going to have a few different things. Maybe like I am going to put a refrigerator out here, and maybe I want to plug a couple things in just for convenience. So this will be another circuit. And the office and these two little areas, which are just going to be mainly storage, they're all going to be on their own circuit. And the only reason I'm putting an outlet here is because if I ever decide to change anything, I still have an outlet in each one of these areas. I don't want to kind of corral myself and, you know, not give myself the option to change these out to do something later. And then the little air compressor room. So I'm just going to put an outlet here. Just, I don't know why I might need it. I don't know if I want to put a heater or something in here, just something small. So it'll be on its own circuit. And then the air compressor is actually going to have its own circuit as well. So if I ever want to put a bigger air compressor or something in here, it'll have its own power and won't be tripping anything out. I might also put a automatic garage door opener on this. I saw some pretty inexpensive, pretty neat little openers that they make that just kind of fit in the end of these. Like little drum that they have in the door, and you can actually sit there and control them from your phone and all kinds of stuff, and it'll just roll them up. So recently I was at the Pittsburgh Home and Garden Show, and I was just pricing garage doors, you know, like the insulated nice doors, you know, just seeing what they would cost to install in the whole thing. And they're about $2,000 for the one that I need for the size and for the insulated door and everything. And that is installed, but I don't think that's going to happen anytime soon. Something to always keep in mind as well, whenever you're doing any type of electrical work, is there's always codes to everything that you do. One of the codes they have is how far outlets can be off from the floor, or how far they should be off from the floor, and how far switch boxes need to be off the floor. I have these 48 inches from the bottom, and from the bottom of these outlets, it's 18 inches. A lot of people in garages, they'll put their outlets, you know, 4 feet or whatever. I like mine a little bit lower. We live on top of a hill. I don't think it's going to flood here anytime soon. And I'm pretty careful, so I don't think I'm going to go wreck into anything. So I'm going to get started, try to work around some of this garbage that I got in here. This has been super nice to have this shop to just be able to work and then slowly sit here and finish the inside. But this place is still a complete wreck. I get it cleaned up and then it's a wreck again. For those of you that saw my daughter's birthday party pictures, we still have a bunch of the balloons left over. And if you watched our gingerbread shoot 'em up video after, I can't remember what video it was one of the framing videos. We like to recycle, not necessarily like paper and cans of things, but we like to recycle decorations. So we'll use them as decorations and then we shoot them up, so at least they get used twice. Here's some of the boxes I'm going to be installing. So what I want you to kind of understand is there's really no difference in any of these boxes except for the size. Like this is a fiberglass box, but they all serve the same function. So when you go to the store, if you see me do this and maybe I'm using gray boxes or blue boxes or something, you know, don't panic. Just understand that, you know, depending on what they have in, especially with COVID, maybe they don't have exactly the same box, but they all function the same way. Same thing with these fixtures. This one's a little bit smaller, so maybe you want to use, you know, these bigger boxes. These are exactly the same. One's just blue. These are the double boxes, and I already showed you the triple box that I already have hung up. I like these plastic boxes better than these fiberglass boxes. I just find them a little bit easier to work with, but it doesn't really matter. The main thing is there's these little tabs that you want to make sure that these sit against the stud, because that gives you your setback for your drywall. So if you have this sticking out, say you leave like 1/4 inch or something between the stud and this little tab, then that box is going to stick out and you're going to have a heck of a time trying to get everything to look right when you get your outlet or switch in place. For these, it's kind of the same. They just kind of have like these little tabs. So make sure that whenever you put these in, you put them in correctly so they don't stick out too far, but you also don't want them sitting back too far either. And instead of carrying boxes around and a tape measure and everything else, what I'll usually do is put an X where I want a box, and then put an arrow, whichever side it's gonna go on, and just measure up to 18 inches, put a mark, and then I can just go back later, throw all the boxes in real fast. In this area, probably isn't happening right now. In the office right here where the desk is gonna be, I'm gonna put an outlet at 18 inches, and I'm gonna come about 40 inches and put in an outlet. And so if I need to plug something in underneath the desk, I can plug it in. And then up above the desk, if I need to plug in a computer or something, I'll have this outlet here. So I'm not gonna put any outlets over here on this side, because I'm just gonna have some bookshelves and things. I don't think I'll need them. And I'll have this outlet right here along the wall if I need to plug anything in. So there is an outlet underneath the table over there. And I already have the box put up in the ceiling. I did that before I even started filming today because I need to get some of this stuff out of my way. And I figured I can at least get the insulation up and push everything back out of the way, and it can just stay like that for a while. So I'm not going to use the lights above the storage areas that often. So this light and the light in the air compressor room are going to be on the same circuit. And I'm just going to put a double box here. So I'll be able to flip on the light. Light in the air compressor room will come on. That light will come on. But obviously I'm not going to spend too much time in the air compressor room. So these won't get used that often anyway. And since it's going to have a double box, the other light switch is going to be a 20 amp switch that'll run the air compressor. So whenever I want the air compressor to run, I can just come over here, hit the switch, it'll turn on, and then without having to goof around inside the air compressor room, I'll just be able to come over, turn it off. In the air compressor room, I am going to put this outlet at 4 feet. So by the way, the reason I have so many different types of boxes and stuff wasn't supposed to be for educational purposes. With all the side jobs that I do, I usually just try to keep enough materials on hand where I'm not constantly going to the store. And whenever they have a few things in stock, I'll just grab them just so I have them for the next job. And I've just kind of been hoarding boxes for a little while, knowing that this was coming up. So that's why I have so many different types. And thanks to COVID, they give you tons of variety. You just kind of take whatever you can get. So the doorway in the office is 2 2x4s thick. So consider what's going to go on here is you're going to have a door that's going to fit inside here. Then you're going to have some trim, and then what happens on this other side? I'd like to put a switch as close as I can to the door, but the issue is if I go mount it right here, I'm going to be kind of stuck with the door and the door casing and everything. So what I'm going to do is put another 2x4 on here, about a foot long or so it doesn't split out. Just nail it on the inside. That'll give me another 1.5 inches of space. So whenever you get close to a doorway or a window or anything like that, if you need to, pad this wall out a little bit, put a board or two on here to get that switch out of your way so it doesn't cause you a problem later. Okay, I don't have all the boxes in place, but I have enough to do some damage. So we're gonna start out at our panel box. And what I've already done is I've ran the hot wire up to make this box hot. And what this is doing is this power comes in, goes to the switch, and then I have a piece of Romex that goes up and over and then to this light. So out of necessity, I just threw this one light in, and it's actually where that box will eventually go when all the joists are in. Now that I have the hot running out of the panel box, the hot wire is going to come into this box and it powers that light. But what I need to do now is run a wire that's going to always be hot from this box over to this box, which is going to make this area light up. Then the hot wire is going to come over to another box that's going to be right here that I can't get to right now, which will power this light up here. Then it's going to jump over to the office, and it's going to come over to this box, so to make this box hot. Then there's going to be a box here, which will power this light. Then that hot wire is going to continue over to that box over there, which will then power this area over here. So think about what I just explained is this. Here's our panel box with our breaker, 15 amp. So we're going to run that Romex over. It's going to hit the first box. Then that hot wire is going to continue on, hit the second box, third box, over to the office, and then the next box, and then that double box. So all throughout all of these boxes, there's always one wire in there that has power, the hot wire. And then all you're doing is with your switch, actually let's just make a switch out of each one of these. So let's just say this is your switch. Now all you're doing is you're creating a branch circuit to go up to each one of the lights. And it's your switch that's controlling the hot feed that goes up to the light to make it power on. Okay, I'm gonna get that main hot wire ran. Remember that the box is hot up to this point. That's how the switch works. So the wire is gonna come out of here and just hit every box along the way, like I had it drawn out on that page. So what I need to do now is run the wires from the boxes up to the boxes which need to get mounted here. So I'm just gonna come 18 inches off from the front over to the middle, and I'm just gonna put it about there. It'll be pretty close to the middle. And just like how this situation's ran here, it'll basically match everywhere else. So you definitely want to make sure you label the wires once you start getting a bunch of wires in a box. If this is the end of a run, or if I'm only putting 2 wires in a box, I'll usually just not worry about it, because I know which one I pulled for what purpose. But in this one, since I have 3 wires, I labeled them. So this one is the light. This is the one that goes to the light. This one is the next light. This is the one that jumps from this box and the next box to make that box hot. And then this is the feed. This is the one that came from the last box. It's going to be hot. I should have said something a little bit earlier about these staples. So whenever you come out of a box, it's code to staple within 6 inches of where the wires go into the box. And you want to make sure that these staples are tight, but that they don't damage even the jacket. Because if you damage the jacket, you don't know how damaged the wires are underneath, you know, inside the jacket. So you want to be careful They need to be snug, but not like crimping down and crushing them. And they actually have a flat spot here. And so you can actually get that pretty tight against the wire without damaging the jacket. So I'm gonna leave the wire just hanging there. I'm gonna do that a couple times when I do the outlets. I don't know, like I said, I'm not gonna buy these joists right now because they're ridiculously expensive, and I guess this garbage in Ukraine isn't helping either. Supposedly the price of lumber is supposed to stay up or even go higher because now you're messing with or somebody's messing with the lumber over in Europe. So I guess that somehow affects us too. So all I have left to do regarding the lights is just hang the light boxes. It'll look, like I said, it'll look just like this one. There'll be the box that has the feeds in it, and then it'll go up and it'll go in the light box. So I just have to do that in the office, and then these 3 bays here. And after that, it'll just be running the 3-way switch like I talked about a couple of videos ago when I had showed how the 3-way switches work. I'm gonna do that, finish that circuit up in the next video, and then also get all of these receptacles wired in and actually get them wired into the box. The lights, I want to be careful right now because I still need to do the drywall and insulation, so I don't want to get too far ahead of myself. But with the receptacles, I think it'll be okay to put some of them in. So I've got about 1 more week of busy side job work. The COVID stuff messed stuff up, backed up a bunch of materials, and then all of a sudden for the past few months, materials have just been coming in like crazy. So hopefully it'll calm down here pretty quick and I'll be able to keep working pretty hard on this. I definitely want to get the wiring in, get it insulated, and then I want to do the drywall, at least on the sides. Obviously I can't do the ceiling, but at least get all the sides done, and then I could start moving in all my tools and get everything organized. Then when I actually go to finish the ceiling, I can just put, you know, drop cloths and plastic and stuff down to protect everything, finish the ceiling, and then it'll be a done deal. We appreciate you watching. We hope to see you next time. Thanks.